Hi everyone, welcome to Chip Ride. In this video, we are going to again see PCB design, and in this, I'm going to design a simple power supply circuit, and we will see how to place the connectors, how to draw the proper traces, placing of components with an actual circuit. So first, I have the Diptrace launcher here. I'm going to go with the schematics. So what we have to do is first we will need the power supply components here. So what we will have to do is first you can see here already in my previous video I have shown you the library part here where we have the capacitors, connectors, all those things. So here we can just check for some connectors. You can see we have different connectors. So we will have to check for connectors which is power connectors. Something like this, whichever connector is okay. So we have many connectors here. Battery holders, power DC. So maybe we will choose this connector here. We will place it here. Now what we will have to do is bring the transformers. Let's check, we have some transformers, power. So let's check some PCB transformers here. Maybe this will be good for now. We can place it here like this. So these are PCB mountable transformers. Now what we will have to do is, now you can see whenever we place, we have the connectors name here, J1, T1, all labelings properly done. Next we need the diodes for bringing up the bridge rectifier. So general components, here we can find some diode. So we have diode with pattern here. So this one we will place here, and one more diode here. Next, this is our bridge rectifier of the power supply here. And next, so this is going to be a simple power supply, basic power supply, where we are going to have a rectified output. So we assume like we have some 12 volt in, and then we are going to get 5 volt out. Now we will have ICs also, typically regulator ICs, all types of ICs here. Let's check for some voltage regulators here. We need 7805. So if it takes time like this, what we can do is simply use this find component option here. Then we can just type 7805 and apply filter, and just move this window so that we can see the pattern. We have SMD type here, through hole type, everything. So basically we can select this 7805A, which is actually the regulator. Next, what are the other components we need is, we'll go for the capacitors. So cap will have an electrolytic capacitor. Assume we have this. Okay, we will take this capacitor here. Now next is we will need another capacitor, simple capacitor, Microcap. Maybe we'll take this here. So for our output we can have some connectors which something like this, a 2-pin connector. For DC filtering we can have another capacitor similar as a capacitor here. In general we can select cap, something like this. Now assume we have all components here. What you will have to do is next draw the connection here. So select this is going to be a VCC pin, and these two we can short. From here we can connect to here, and then we'll first draw the bridge rectifier. Okay, now what we will do is this is going to be our ground line. This is going to be a simple power supply design. Now let's just arrange it properly. Okay, so that now the circuit looks neat. So you can see that when you just keep the cursor on the net, whenever you draw the first net, this is going to be net 0, net 1, net 2, net 3. So net 3 is, this is what is like we did. So whichever net you have started, that will be having a sequence, like this was our first net, and then this was our second net 1, and then this is net 2, and then net 3, like that. Now these lines are actually not short. It's when you touch, you can see that it is blue, and wherever it is blue, it's all short here. Now we have one connection left out, so that is going to be for this capacitor. Next, so now I assume my circuit somewhat looks good. Okay, now I have the DC jack, so I'll give an AC input here through an AC adapter or something like that, and you can place any other connector, power connector here, and I'm just drawing, like I'm giving a simple input here, and I have a transformer here. This can be PCB transformer, or basically you can keep the transformer outside, so you don't need this transformer part also. So what we'll have is we'll have the basic power cord connected to the transformer, and then the output from the secondary can be connected to the connector, and we'll have the next stage of bridge rectifier like that. Maybe we can keep like that also. For assuming that everything is lying inside a PCB, I'm just drawing a simple power supply circuit here. Now what we'll have to do is we have to be very choosy about the component patterns, everything, whatever we are going to place here. And now next step is, as earlier you can see in my previous videos, we have electrical rules check, where the rules setup has everything checked. Then we are going to run the electrical rule check, and then so after there are no errors, we have to click on file and then convert to PCB. Then the PCB layout will be invoked. Use schematic rules. Then we have the component and the patterns of the components here. So to place the dimension and properly draw, you will have to click on place dimension, horizontal, vertical, depending upon that. You can just click here, click on the quadrants, draw the dimensions. This is going to be horizontal dimension, this is going to be vertical dimensions, something like this. After placing this, we will have to click on objects, place board outline, and then click on the starting point, and then one more click here, and then one more click here, and then one more click here, and then click enter. Now we have the board mechanical layer where we'll be placing the components, and this is actually the PCB board, the mechanical layer which we are drawing here. So we have the dimensions. We have to properly place dimension with respect to the enclosures, all those things based on the requirement. All those things we will have to first place the dimension and then only draw the board outline of any shape. So basically for any shape, any size, we will need the dimensions, and then we will have to first place the dimension and then only draw the board outline. So what we are going to do here is simply we are going to select, for practice, we are going to select object, board points, create rectangular board, 2000 mils cross 2000 mils will be our board. Then click OK. We can see 2000 cross 2000 board has been created. Now what we will have to do is place the components. So the connectors placed. Now I'm going to rotate the component so that my tracks are I am able to draw the tracks easily, and then trying to place the diodes. Okay. Next, the voltage regulator, then the cap following symmetry as like the diodes, and then the connector. So the input connector and the output connectors are placed on the edges, and then we have one more diode which is hanging somewhere here. Okay. Let's see if we can draw somewhat. I think it's fine. We can be able to draw the traces. So we have the red lines. Now what we can do is go to the bottom side and then start drawing the traces. Click on add traces, then connect, connect here. So when you place the component properly, we'll be able to route very fast. So here I don't have enough space to connect the other track. Move this track like this a little without disturbing it, so that I can bring the other trace here. So this track is disturbing me now. Let's see what we can do with that. Maybe in such case, I'll have to go to the top side, check if I can rotate this component. Then let's go to the bottom and route. Even we have to rotate this component as well, and this again, and this again. Now we can fix it at the bottom. We have the tracks easily connected now. So now we are able to properly design the power supply circuit. Now we can go to the top and see how it looks. So you can see when we have followed the symmetry where the components are lying, similar components are lying in a single pattern, and you can see the capacitors in the same line, and now connectors at the edges. So you should concentrate on these things. Then the design at the bottom side. So all these things have to be concentrated properly. Then the importance to the placement is like when you're placing the components properly, then we'll be able to draw the traces faster. So 95% importance to the placement and 5% importance to the routing. So placement is very important. Then if you have to if you want to place this mounting holes are like wherever the according to the enclosure we will have to plan the mounting holes. For now I'm just placing a mounting hole on the corners. Actually this has to be placed properly with measurements with certain distance from the corners or center wherever enclosure requires. So I'm just placing mounting holes here. Now let's look into the 3D design. So here the packages, library packages for diodes are missing, it seems. So anyway, we have the transformer, the connector here, and then the capacitor, I7805 IC, regulator IC, for the capacitors, then the connectors. So we have everything, and we have the tracks below. So you can see the tracks here on the mounting holes on the corners. So this is how our PCB will look like after placement of the components. Now what you can do is just try to take some simple circuit and place like this properly, give importance to the placement, and then draw traces. Or you can simply take a power supply circuit, what I have selected, and try to just place the components and draw the traces, which will help you to learn PCB. And finally what we'll have to do is we can actually see the layers separately. So say if you don't want the top seal which says about the component here, you can remove that and we can even see remove this bottom silks. Now you have the pads here. You can see the tracks. Now what we'll go to the bottom, what we'll do is to go to the bottom, then just click on bottom. We can see the tracks here, completely only tracks, and on top we don't see anything like the silk screen, all those things. If you want to see that, you can click here and we can see we have the silk screen on the top. So sometimes we have double-sided design, we'll have tracks on the top side and the bottom side. In such case, we will have this top tracks also, so that can be seen. And finally, if you want to export, we'll have to export to Gerber X2, and then here also we can see I have a preview of all these things. So you can see, like, I'll just click here on top and then just click and it shows the pads, all those things of the component. Bottom, it will show the tracks with pads. So these are the information which will be passed to the machine. Machines help in constructing the PCB with tracks properly. So these are machine related information which we'll have to export. So what you can do is just click on export and save the files, and then you can give it to the manufacturer, and the manufacturer will then print the board and give you. But we will have to, before following these things, we have certain rules to be followed also, which is actually the design rule checks. I will cover about the design rule check and how to export the files and relay information to the manufacturer for a simple PCB design, and then we will be able to understand how to give design a PCB and give it to the manufacturer, and how to just design tracks, spaces with pads, all those things with respect to the manufacturer's requirements also. So this is what I wanted to tell you in this video. We'll meet in another video. Thank you. Thanks a lot. Bye bye.